set to 0. If salary is greater than expenses, I'm going to print out the savings for the month, else I'll print out loans taken. And observe that I have a third print statement here, savings and loans, and this third print statement is outside of my if block as well as my else block. This third print statement will be printed out to screen whether the condition evaluates to true or false because it is outside of the if as well as the else blocks. For my current set of values, the condition salary greater than expenses evaluates to true, so the statements within my if block will be executed. I'm now going to go ahead and edit the values assigned to the salary and expenses variables so that salary is now less than the expenses that I incur. If I hit Shift Enter on this code cell once again, this time the condition evaluates to false, which means the statements in my else block will be executed. I'm going to have to take $260 worth of loans to tide me over for this month. You can use if conditional checks with lists and dictionaries as well. Here are three lists that I've instantiated: classic cars, sports cars, and planes. Here is a simple if check which invokes a built in function. If the length of classic cars is less than 5, print out that isn't really a very long list of classic cars. The condition evaluates to true and the statement is printed to screen. I'm now going to run a series of if checks and print out different statements based on which check evaluated to true. I have the name of a car assigned to the transportation variable. I'm then checking to see whether my transportation is present in classic cars. If it's true, then I'll print out to screen your type of transportation is a classic car. Notice the use of the in keyword to check whether a particular element is present in a list. Next, I'll check to see whether transportation is in sports cars. If yes, then I'll print out your transportation is a sports car. And the third if check is if the transportation is in the list of planes, then I'll print out your type of transportation is a plane. The print statement that will be executed depends on which of these if conditional checks evaluate to true. My type of transportation happens to be a sports car. I'm going to change the value assigned to the transportation variable and switch it over to Mustang. This time, a different if conditional check will evaluate to true. The Mustang for me is present in the list of classic cars, and the first if check evaluates to true. I'm going to change the value assigned to the transportation variable once again to be the A380, and this time when I execute this code, the third if check evaluates to true, and my type of transportation is a plane. If statements can be used to check for the presence of a key within a dictionary as well. Here is a dictionary of luxury cars and their corresponding horsepowers. These are key value pairs. I can use the in command in Python to check to see whether a key is present in a dictionary. If Phantom in luxury cars and their horsepowers execute the print statement. The Phantom is a key in this dictionary, the condition evaluates to true. Just like the in keyword, Python supports the not in keyword as well. The Maybach is not a key in the luxury cars and their horsepower dictionary, and this print statement will be executed. Python allows you to check for multiple conditions using if in combination with elif. I have a variable here called math score which I've initially assigned to 20. Take a look at my first if condition. It checks to see whether math score is less than 20. In that case, it says it's not a great score. If this condition is not satisfied, we go into the next elif block. The elif condition is checked only if the first if condition is not satisfied. If math score is not less than 20, we'll check to see whether math score is less than 50. If this elif condition evaluates to false, only then will we move on to the next elif block. We'll then check to see whether math score is less than 80. And if math score less than 80 evaluates to false, we'll move on to the final elif block. We'll check whether math score is less than 100. Let's take our current value for math score equal to 20. If math score is less than 20, well, that evaluates to false, which means we'll go into the first elif block. Here, math score less than 50 will be equal to true and we get printed out to screen. Oh, you can definitely do better than this. I'll now go ahead and update this math score to be equal to 40. The first if condition, if math score less than 20, will evaluate to false. So we get into the first elif. Math score less than 50 will evaluate to true once again. Once again, I get the statement, oh, you can definitely do better than this. Let's change the math score once again upwards to be equal to 60. The first if conditional check, math score less than 20, will evaluate to false. The second elif check will also evaluate to false, math score less than 50. The third elif check, math score less than 80, will evaluate to true, and we'll get the result, ah, you're so close to the highest grade you can get. Let's change our math score to be equal to 90. This time around, our first, second, and third if checks will all evaluate to false, less than 20, less than 50, and less than 80. And our final elif check math score less than 100 will evaluate to true, and we'll get the statement printed out to screen. You did great at math. When you're using if elif statements, the order matters, and you have to be mindful of this. Take an example of these if elif statements here and see what's wrong. Remember that these if elif statements are evaluated from the top to the bottom. My math score is 20, and my first if check checks to see whether math score is less than 100. With a score of 20, this conditional check is clearly true, and I get printed to screen, you did great at math with just 20 marks. Based on the condition that you're trying to evaluate, you need to get the order of your if elif checks right. We messed up the order here, which is why we got this strange result. Even with a math score of 90, you'll get printed out to screen. You did great at math because the first conditional check evaluated to true. Sometimes, when you're writing code, you might want the same set of operations to be performed over and over again a specified number of times. This is when you would use a for loop in Python. We'll start off by defining a for loop to iterate over all of the elements in a list. Here is a list of classic cars, and there are three elements within this list. Here is what a for loop to iterate over the elements of this list looks like. For car in classic cars, print car. So, what exactly does this do? Classic cars contains three elements. The variable car will take on the value of each of these elements in turn, and each of the cars will be printed out to screen using the print car statement. In the first iteration of the for loop, the variable car will have the value Pierce Arrow. Pierce Arrow will be printed out to screen. It will then take on the value Oldsmobile. Oldsmobile will be printed out to screen. And finally, in the third iteration of this for loop, it will take on the value Mustang. Mustang will be printed out to screen in the third iteration of the for loop. The for loop is now complete now that we've come to the end of this list. If you print out the variable car at this point in time, its value will be equal to the last element in your list, Mustang. The for loop essentially allows you to execute the print car statement over and over again for different values of car. Let's set up another list with a different number of elements. This is a list of sports cars and it has four elements within it. Exactly like we did before, we can run a for loop to iterate over all of the elements in the sports cars list. The variable car will take on the value of each sports car in turn for each iteration of the list. After four iterations equal to the number of elements in the sports cars list, we will exit out of the for loop and the value of the variable car will be equal to the last car in our list, the Veyron. In this manner, the for loop is extremely useful to work with lists which have a finite number of items. You can iterate over a list of characters using a for loop as well. Observe that we have defined this list of characters right within our for statement. The character variable that we have defined within this for loop will take on the values of each of these characters in turn, and these characters will be printed out to screen. You can use a for loop with a string as well. For character in Phantom, will iterate over the individual characters in this string and the characters will be printed out to screen. Iterating over the characters in a string works in Python because a string is essentially an iterable. You don't really need to know what exactly that means, but you should know that it's not possible to iterate over the individual integers in this very long number using a for loop. Observe that we get an error here that says the int object is not an iterable. Integers cannot be iterated over. We've seen that you can iterate over the elements in a list. You can also iterate over elements in a tuple, as you see here on screen. Cameras is a tuple. A for loop works with tuples exactly like it did with lists. You can run a for loop to iterate over each of the cameras in your cameras tuple and print out the camera to screen. For every iteration of your for loop, the camera variable takes on a value of another camera element in your tuple. For loops are not just for printing out stuff to screen. Let's make our for loops a little more complicated and more interesting. Here is a list of integers called numList. I'm now going to run a for loop to iterate over every integer of this num list, and within my for loop, I'm going to perform a conditional check. Remember that the num variable takes on the values of the different elements of this list. If the current value of num is less than 500, I'm going to print out less than 500 to screen. If it's greater than 500, I'm going to print out greater than 500. Execute this for loop, and here is the result right here on screen. For the first iteration of this for loop, the num variable had the value 100. Num less than 500 evaluated to true, which is why we see printed out on screen less than 500. For the second iteration of this for loop, num took on the value of the second element of this list equal to 800. The if checked to see whether num was less than 500, that evaluated to false. We moved into the else block and greater than 500 was printed out to screen. For loops in Python are often used with the range function. The range function is a built in function available which generates numbers in a specified range. Range of 10 returns all numbers from 0 up to but not including 10. That means all numbers from 0 through 9. Invoking the range function returns something known as a range object, and this range object can be converted to a list or a tuple. You can pass in R to the tuple function, and this will create a tuple with this range of numbers. Observe that the range starts at 0 and goes up to but does not include 10. The range object can be converted to a list as well by passing in R to the list built in function. This will generate a list of numbers starting from 0 and up to but not including 10. In this manner, you can use the range function to generate different ranges of numbers. Range of 2, 10 generates all numbers starting from 2 and up to but not including 10. And this range object is converted to a list using our list function. Let's try this once again. Let's get a list of range -4 to 8. We get all of the numbers in the form of a list starting from -4 up to but not including 8. The range object returns a range of numbers, and you can use this along with a for loop. For I in range 6, print I will print out all numbers from 0 up to but not including 6. Now, this is easier to understand if you imagine that the range object is essentially convertible to a list. The list includes all numbers from 0 up to but not including 6, and we are simply iterating over that list. That is the best way to imagine how a range object works. Let's try this once again. For I in range 2, 8, print I. This will print everything starting from 2 up to but not including 8 up till 7. The range function can take in a third input argument for the step size as well. This will generate all numbers starting with 2 up to but not including 11 in steps of 2. So this range object gives us 2, 4, 6, 8, 10. Let's try this once again. For I in range 2, 11, 3. Start with 2, go up to but do not include 11 in steps of 3. This gives us the numbers 2, 5, and 8. The next number would have been 11, that's outside of our range. The range object only accepts integers as input arguments. If you try to specify the range of a floating point number, well, that's an error. The range function is often used to specify the same set of operations a certain number of times. Let's say you want to print out Python is great 7 times. You'll say for dash in range 7, print Python is great. The use of the underscore instead of a real variable indicates that you want to ignore the value produced by the range function within the for loop. You can use for loops in Python to iterate over the keys of a dictionary as well. Here is a dictionary of names and ages. Names are the keys, ages are the corresponding values. When you run a for loop in this format for key in names and ages, you'll automatically iterate over all of the keys of your dictionary. Observe that the print statement prints out John, Alice, Bill, and Dave. These are your dictionary's keys. If you want to use a for loop to print out all keys and values within your dictionary, you'll run the for loop to iterate over all keys and look up values by key. The key variable in the for loop will iterate over dictionary keys, and you can look up within the dictionary the value associated with each key. And this is how you can get the keys and values printed out using a for loop. Python dictionaries have a function called keys. You can invoke the keys function on a dictionary to get access to all of the keys within your dictionary. And using this keys function, you can iterate over all of the keys using a for loop as well. This is a for loop that iterates over all of the keys in our names and ages dictionary. Dictionaries in Python have a function called values, which give you access to all of the values in your dictionary. And you can use a for loop to iterate over the values of your dictionary using the values function as well. The items function on a Python dictionary returns the key value pairs within your dictionary in the form of a list of tuples. Here is a list of tuples where the first field in every tuple is the name of the person, that is the keys in our dictionary, and the second field in each tuple are the corresponding ages. You can use a Python for loop to iterate over this list of tuples as well for key comma value in names and ages dot items. Because we are iterating over a list of tuples, we have two variables here, key as well as val. And here is the result of running this for loop. In your program, if you know upfront how many times you want a certain sequence of operations to be executed, you'll use a for loop as we saw in the previous clip. But if you have no idea upfront how many times you want your loop to run, and it's based on a certain condition evaluating to false or true, that's when you'll use a while loop. A while loop is a special kind of loop that does not run a predetermined number of times. It'll run so long as your condition evaluates to true. Set up a while loop by using the while keyword followed by a condition. Our condition here is false. And after the condition, you have the colon, and then comes all of the statements within your while loop. This while loop that we have here has exactly one print statement within its body, but the condition is false. If the condition is false, the statements within your while loop will not be executed, which is why nothing is printed to screen. Let's set up another while loop where the condition is always true. While true. Now, this condition never evaluates to false, which means that your print statement will be executed over and over again, all the way through to infinity. What you've executed here is an infinite loop. Now, there is no way to break out of this except by hitting this stop button on your Jupyter notebook. This will forcibly interrupt the kernel and cause your while loop to terminate. You can scroll down at the very bottom and you'll see that there was a keyboard interrupt which forced your while loop to terminate. Otherwise, it would have gone on all the way through to infinity. Well, in your Jupyter notebook, your kernel would have crashed before then. So, while loops need to be terminated explicitly. Let's understand how while loops work by taking a look at another example. I've set a variable a here to be equal to 5. This is the value of a when the while loop starts. My while loop has a sensible condition here. So long as a is less than 10, I want to print out the value of a. What do you think will happen when you execute this bit of code? Try it and you'll find out. Unfortunately, you've caused another infinite loop. 5 is printed over and over again, and you have to forcibly interrupt your kernel once more. This while loop will be terminated only with a kernel interrupt. This is because you wanted your while loop to be executed so long as a was less than 10. A is equal to 5. It does not change within your while loop. It was always less than 10. The condition always evaluated to true, and you ended up with an infinite loop. When you're working with while loops, it's important that you specify the terminating condition correctly. Here I have a variable b which I've set to 7. So long as b is equal to 7, I'll print out b to screen. When the condition is true, that is b is equal to 7, I'll enter into the body of the while loop. I'll print b out to screen, and immediately after that, I update the value of b. b is equal to b multiplied by 2 will change the value of b, and my while condition will then evaluate to false. After running through the body of the loop once, the value of b will change and I'll come out of the while loop. 7 will be printed to screen. The value of b is now equal to 14 thanks to my b is equal to b multiplied by 2. I updated the value of the variable b, and that's what caused my loop to terminate. And this, in essence, is how while loops are used in the real world. You have to ensure that the terminating condition is met so you don't get into an infinite loop. Here I've assigned the value of c to be equal to 45, and so long as the value of c is less than 50, I print c out to screen. Now, this loop essentially can go on forever unless I change the value of c within the while loop. That's exactly what I've done. For each iteration of the while loop, I increase c by 1. C is equal to c plus 1. And executing this code gives me this result. C is initially equal to 45 in the first iteration of this while loop. I print out 45 to screen, then I increment C by 1 to be equal to 46. In the next iteration of the while loop, C is still less than 50. The condition evaluates to true, so we re-enter the body of the while loop. 46 is now printed out to screen. C is incremented by 1 to 47, 48, 49. The while loop is executed for each of these values of c till we hit 50. That's when the while loop condition evaluates to false and we break out of the while loop. C in the final iteration is equal to 50 at the end of this while loop. While loops can be confusing and they involve a bit of practice. Let's try this once again with another value. D is initially equal to 64 and I want the while loop to execute so long as D is less than equal to 75. I'll print out the value of d for each iteration of the while loop and I increment d by 3 in every iteration as well. The statements within this body of the while loop will be executed so long as d is less than equal to 75. The minute d crosses the value 75 and at the end of the last iteration you can see that it's 76, that's when the while loop condition is no longer satisfied and we come out of the while loop. When you use while loops, you have full control over the variable that controls how often you re enter the body of the loop. I have a variable p here initially assigned the value 5. So long as p is positive, that's what while p says, we will enter the body of the while loop. While p is equivalent to while p is greater than 0. For every iteration of the while loop, I decrement p by 1 till at some point in time p will be equal to 0. That is what it is at the end of this loop. The while condition is no longer satisfied. That's when we come out of this loop. The body of your while loop can contain any number of statements, can contain any Python code. Here I've initially initialized the variable num to be equal to 10. So long as num is less than 20, I'm going to print out to screen num plus num, whatever the current value of num is. For each iteration of this while loop, I increment num by 2, num plus equal to 2. In the first iteration, num will be equal to 10. 10 plus 10, 20 will be printed to screen. In the second iteration, num will be equal to 12. 12 plus 12, 24 is printed onto screen, and so on. This will go on all the way up to 18 plus 18 equal to 36. When num is equal to 20, the while loop condition will no longer be satisfied and we'll come out of the while loop. While loops are very, very useful when you want statements executed till a condition is satisfied. Here I'm going to take as an input from the user the name of a car. The input built-in function in Python allows you to specify a user input. So car is equal to input, what's my favorite car? So long as the car specified by the user is not equal to Aston Martin, I'm going to run a while loop, and this while loop will take an input from the user once again. I'm going to assign this to the car variable once again, and this while loop will run till the user guesses correctly that my favorite car is the Aston Martin. Hit Shift Enter, and this will bring up a little dialog allowing you to specify user input. This is thanks to the input built in function. Let's say my first guess is the Toyota Corolla. Now, this is obviously not equal to the Aston Martin, which is why I get wrong guess again. Let me try again. I'm going to guess the Tata Nano this time around. Obviously, this is not equal to the Aston Martin. I get wrong. Guess again. This time, I'm going to guess correctly. I'll type in Aston Martin. My while condition is no longer satisfied. Car is now equal to Aston Martin, which is why we get out of the while loop. When you're executing statements within your loop body, whether it's a for loop or a while loop, you can get finer grained control over your execution using specific Python keywords, the break, continue, and pass keywords. Let's start with simple iteration using a for loop. I'll run a for loop to iterate over all of the cars in this list of classic cars. For car and classic cars, I'll print car out to screen and then I use the break keyword. The break keyword is what I use to break out of the loop, that is early stopping. When Python encounters the break keyword, it'll simply stop iterating through the loop. So when we run this for loop, the car variable will take on the value of the first element in the classic cars list, that is the Pierce arrow, and then break out of the loop. No code will be executed after the break. And if you take a look at the car variable, it'll contain the value, the Pierce arrow, that is the first element in our list. The break statement, as we used it, was kind of boring. Break statements become more interesting and powerful when you combine them with conditional operations, such as an if statement. I run a for loop here to iterate over each car in my classic cars list. I print out the name of the car, and if the car name happens to be the Corvette, I'm going to print out this is my favorite and then break out of the for loop. When you run this code, you'll find that every car up till the Corvette and including the Corvette will be printed. When the variable car is equal to the Corvette, the if statement will evaluate to true. We'll then go into the if block of statements, we'll print out this is my favorite, and then break will be encountered, and that will get us out of the for loop. The remaining car names will not be printed. The value of this car variable at the end of this loop will be equal to the Corvette, because when car was equal to Corvette, that's when we broke out of the loop. When Python encounters and executes the break command, no code after the break is executed. Let's see this example. I'm going to iterate over all of the cars in the classic cars list. If the car is equal to the Corvette, I'm going to print out this is my favorite and break out of the loop. After this if conditional check, I still have some code within the for loop, which is a print statement which says still within the for loop and prints out the current car. When you run this bit of code, you'll print out all of the cars, the Pierce Arrow, the Oldsmobile, the Mustang, till you come to the Corvette. When you come to the Corvette, your if conditional check will evaluate to true. You'll print out this is my favorite and then break out of the loop. As soon as Python encounters this break command, it will not execute any more code within the for loop. It will simply jump out of the for loop. The print statement that says still within the for loop will not be executed. I'm going to run a bit of code that is a little more complicated. I have a list of numbers stored in the numbers list variable. I've then set up a for loop to iterate over all of the numbers in this number list. For each number, I'll print out checking and the value of that number. If the number happens to be a multiple of 3, I'll print out multiple of 3, yippee, and break out of the for loop. Otherwise, I'll print to screen not a multiple of 3. Let's run this code and see how we get this result that you see here on screen. The value of the num variable in our for loop is initially equal to 100. 100 is not a multiple of 3. Our if condition does not evaluate to true. So we print out not a multiple of 3 and we head back into the for loop. Num is then equal to 34, 67, 89 up till 78. 34, 67, and 89 are not multiples of 3, so the if condition never evaluates to true. But with 78, the if condition evaluates to true. We'll print out, yippee, this is a multiple of 3, and then Python encounters the break and immediately throws you out of the for loop. Once Python sees the break, it will not execute the final print statement within the for loop. No more code will be executed within the body of the for. Now that we understand how the break keyword works within a loop, we can move on and discuss the continue keyword. Here is a list of classic cars. I'll run a for loop to iterate over every car in this list. If car is equal to Mustang, I'm going to continue. After this if conditionals check, I have one more line of code within my for loop, that is printing the car out to screen. I'm going to execute this bit of code and we'll see what the result looks like, and I'll then explain this result. When Python encounters the continue keyword, it basically says skip this iteration of the loop but go on to the next iteration. So initially car is equal to the Pierce arrow. The if condition is not satisfied, we go out and print the name of the car out to screen. Car is then equal to Oldsmobile. The if condition check is false, continue is not executed. We then go on, car is now equal to Mustang, and when car is equal to the Mustang, Python encounters the continue statement. In that case, it doesn't come out of the loop, it simply skips the execution of the remaining code in this loop and goes back to the beginning of the next iteration. The print car code will not be executed for the Mustang because we have skipped over the remaining lines of code. We move on to the next iteration where the car variable is equal to the Corvette, and then in the next iteration after that to the Alfa Romeo Spider. So continue simply skips the current iteration of a loop. I find the continue keyword far more complicated than the break. Let's look at another example. For I in range 10, the I variable will take on values 0, 1, 2, all the way up to and including 9. We have an if check within this for loop which checks to see whether I is divisible by 2. If I is divisible by 2, we continue and move on to the next iteration and don't execute the lines of code which come after the continue statement. When you execute this bit of code, all of the odd numbers will be printed out to screen because each time I is an even number such as 2, 4, 6, or 8, the continue keyword is encountered by Python execution. The rest of the code will not be executed. That is, the print statement will not be executed, and we move on to the next iteration of the for loop. Continue essentially tells Python, carry on, don't worry about the rest of the code in this loop. Keep calm and continue with the rest of the iterations of this for loop. Here is another example that uses continue. For I in range 10 to 21, so I will take on values starting from 10 going up to but not including 21. When I is greater than equal to 13 and I is less than equal to 16, we simply continue and do nothing. Otherwise, we print I out to screen. When you run this code, this will print out all values of y from 10 up to and including 20 except values 13, 14, 15, and 16. That's when our Python execution encounters continue. If you were to write the same